Hey everyone, this is Michael from Bright Musical Circuits. This is the new clipper bank. So as the name implies, it's just a bank of these 4 clipper circuits, input and output. Each one is going to clip the signal to different levels based on the way the diodes are arranged. There's no controls. It's something you can just easily pop into a patch between 2 points. And I'm working on some voltage controlled clipper stuff for the future, but right now, this is just kind of an add-on to an existing VCA. You probably already have VCAs you like, and so having something that distorts and is a VCA at the same time might not be as useful to you. But yeah, let me move this over to the oscilloscope, and I will show you what you're working with, what it looks like. Okay, so starting out, we've got a triangle as our input, and we're on the softest setting. Each clipper circuit is going to distort a little bit differently. So as you can see, it's really triangular. It's just a little bit softer at the bottom and the top, where it's just cut off a little bit. And with a sine wave, it would be really hard to find the difference between this and a regular sine wave. But then moving on to the next circuit, it's pretty noticeable on the sine wave that it's got a little more trapezoidal, and with the triangle, it's also kind of this more round trapezoidal shape. Moving on to the next, you have this harder, this harder curve here, where it's changing with the triangle wave, and with the sine wave, it's also, this is noticeably hard. And then finally, the hardest circuit, where it's almost like a square wave. Again, this is our sine input, triangle input. It's really hard to tell the difference between a triangle and a sine wave at this point. Now also, you probably have access to saw waves. That's not as big of a difference. Those are already pretty rich in harmonics, so we're not really adding too much to the signal by doing this. You can see it looks different on the scope, but when you listen to it, it's not nearly as noticeable a difference. And with square waves, almost no difference at all when you're using this. Cool. So next, I am going to run this through a VCA first, and then also let me add 1 volt to the VCO. So this is a sine wave set up on the softest clipping. And then here is the next hardest. So you can hear on the attack, it's got this little burst of harmonics to it, and then it softens down as the note decays. And you get a nice kind of percussive, reminds me a little bit of like a xylophone. That's me playing with the release. And then this is a sine wave through the hardest clipper. And then let's try this with a triangle wave going through this setting. So next I'm going to patch it just for education's sake with it going through the distortion before the VCA so you can hear what that sounds like. And it's not that different from just patching a square wave when it's the higher setting there. So With this, the harmonics are more consistent as the amplitude changes, so this might be useful as well for when you're patching. Oh, and then I also wanted to show the effect of... hold on, let me set up something else real quick. So now I've got the VCA out of the circuit. And this is me adding a voltage offset. So if you mix the input signal with an LFO, you'd be able to do something like this. I'm doing this manually with a offset knob on my attenuate offset module. But this is another way you can use this to get interesting waveforms. But yeah, thank you for watching. There's circuit boards available for this, and hopefully at some point I have some more Klipper circuits available too, because I've really been enjoying how this sounds.